In this video, I'm going to create a test lab called Lab1. By building this test lab, I will demonstrate how to set up a Windows Server 2012 Hyper-V failover cluster. The first purpose of building this test lab is to help us become familiar with Windows Server 2012 and some of its roles and features. In particular, iSCSI, Hyper-V and failover clustering. The second purpose of building this test lab is to provide an environment in which we can practice a variety of server-related tasks. I will be building this whole test lab within a virtualized environment. The virtualized environment I'm using is VMware Fusion on my Apple Mac, but you could use a different virtualized environment. The reason for doing this is that I can run the whole environment on one computer. And not only that, once the environment is built, I can snapshot it, and then when I want to practice things, I can revert back to the snapshot. This diagram you can see shows the components of the test lab. Lab1 DC1 will be the DNS server and will service a DNS domain called lab1.local. This will be used by all of the servers to resolve server names to IP addresses and to enable servers to find the Active Directory domain of the same name, lab1.local. Lab1 DC1 will also be an Active Directory domain controller and will service this Active Directory domain called lab1.local. All of the servers will be members of this Active Directory domain and will use it for authentication and authorization. Lab1 MGR1 is going to be the management server. This is the only server that will have the Windows Server 2012 GUI installed on it. The rest of the servers will be server core installations. I will be using the GUI management tools from this server to manage all of the other servers. Lab1 SAN1 will be providing the shared storage that will be used by the Hyper-V failover cluster nodes. This storage will be shared using iSCSI so that both of the cluster nodes can use it. I'll be using the Windows Server 2012 failover clustering feature to build the cluster Lab1 Cluster 1 on the two nodes Lab1 Hype 1 and Lab1 Hype 2. I will be using the Windows Server 2012 Hyper-V role to add virtualization capabilities to these cluster servers, making them virtual hosts that can run guest virtual machines. The three virtual machines I'm going to be creating on these hosts are Lab1 Server 1, Lab1 Server 2 and Lab1 Server 3. By combining clustering and virtualization, we will have virtual machines that can be moved between the two cluster nodes. We can move a running virtual machine from one host node to another host node in the cluster without downtime. This is called live migration. Failover is when one node fails, and the virtual machines on that node will also fail, but then they can be brought straight back up on the other node. The first task is to build a domain controller Lab1 DC1. I'm building this as a virtual machine with one processor, 2 GB of RAM and 60 GB thin provisioned hard disk. The hard disk being thin provisioned means that the underlying disk file will grow as you use it. I'm going to install this with Windows Server 2012 R2 Standard Edition using Server Core. And don't worry, you won't have to keep waiting for installs or file copies, as I'll skip those in the video demo. You can tell I've skipped something when the screen goes blurred like that. Let's set the administrator password. All of these servers are guest machines sat on top of a VMware Fusion host. So to improve the performance, I'm going to install VMware tools on all of them. And while that's happening, I'll explain the reason I'm using server core instead of server GUI for most of these servers. Firstly, when I compared the thin provisioned disk of a server core build with a server GUI build, I found it used 5 GB of space instead of 8 GB. That's 3 GB less. For my 4 servers, that saves 12 GB. The server core has fewer processes and services running, meaning less pressure on memory and processor utilization. Also, this reduction in the number of processes and services that are running improves the stability of the server and reduces the attack surface of the server from malicious intent. I'm now going to use sconfig utility to configure the computer name and after that the IP address. It's always good practice to assign a server IP address as either static or to use DHCP reserved, as you don't want the main IP address to be changing. I'm not going to set the DNS server IP address here as I don't have a DNS server on this test lab yet as part of this test lab. In fact, this domain controller is going to be the DNS server. Now we've set the IP address, we're going to use PowerShell to set up the Active Directory domain lab1.local. This is a two-stage process where first I need to install the Active Directory domain services role and after that configure it. We're going to do this by using the install Windows features commandlet. Okay, I can check what roles and features are currently installed using the Get Windows feature commandlet. If, as in this case, you get more information than you need, you can pipe those results to the Where Object commandlet and use this commandlet to filter the results. If we look at the aliases, we can see that we can use where instead of where object. So we can also write get Windows feature, pipe it to where installed instead of where object installed. I'll show you another way you can filter the results using the like option. You could say, I like this option a lot. Anyway, we can see that it's installed, so it's now time to configure the domain. There's various commandlets you can use to do this. We want to use install adds forest, as this will allow us to configure our first domain controller in a new Active Directory forest. As you can see, our new forest name is lab1.local. And I'm also going to use the install DNS option, as this is going to be a DNS server. The safe mode administration password is a password you would need to use if you wanted to boot the server into a recovery console or into directory services restore mode. We're almost done now. Just need to reboot the server and then check it's okay. As you can see, it's switched so that I'm logging into the domain Lab1. And if we go back to PowerShell and we check what's installed, we should see that we have DNS installed as well. There we are. Let's also go in sconfig and we can see the domain lab1.local. So I'm going to log out now as this is this server built. The second task is to build the management server Lab1 MGR1. I'm building this as a virtual machine with one processor, 2 GB of RAM and 60 GB worth of thin provisioned disk. Out in the real world, the main place I've seen this idea of a management server, also called a jump box, is for the remote management of servers, where the server administrator remotes onto the jump box and from there manages the company's servers. I'm going to be installing this with Windows Server 2012 R2 Standard Edition using Server GUI. Of course, everything we're doing through this management server you could also do remotely from a desktop using Microsoft's Remote Server Administration Tools Pack. Okay, let's set the administrator password. Now let's log back in as a local administrator. Again, I'm going to install VMware Tools. You'll notice the services there are 4 red alerts, and the only reason they're red is because some of the services have a delayed start and haven't started yet. Okay, VMware Tools is now installed and I'm going to log back in as a local administrator. So let's set the computer name through Server Manager, and this is Lab1 MGR1. This will obviously need a reboot. Okay, I'm going to set the IP address. And as well as the IP address, I'm going to set the DNS to our domain controller Lab1 DC1, which is also acting as our DNS server. And setting the DNS here will also allow this server to find the domain lab1.local. So let's now join this server to the domain. Okay, we're in the domain. Another reboot needed. Now let's log in as the domain administrator. And since this is my management server, and the main reason we want to use this server is to manage the other servers through, in essence, GUI administration tools, I want to be able to see a bit more. So let's increase the screen resolution and let's make it high definition and widescreen. But I'll also be increasing the items size on the screen a little bit. So let's make that 150%. So now that we have this server set up, the main thing we want to do with this server is actually use the management tools. So let's install those features. So let's see, we want the failover clustering tools. We want the AD tools, the Hyper-V management tools, the DNS server tools. That's it, that's all the tools we need for this this test Lab1. Let's look in Active Directory users and computers. And there you can see our domain. And if we look in the domain, you'll see our two servers, our member server and our domain controller. Let's also look in the DNS management tool and connect to our DNS server, Lab1 DC1. And in here you'll see our DNS domain and you'll also see the start of authority, which is our domain controller. That's the server which is servicing that DNS domain. In case I need to resolve internet DNS entries, I need to set the forwarder. For my environment, this is my internet router, 192.168.1.1. The third, fourth and fifth tasks are to build the servers Lab1 SAN1, Lab1 Hype1 and Lab1 Hype2. I'm building these three servers in exactly the same way, except for the virtual hardware specification being different. So I'm only going to show you the building of the first server, Lab1 SAM1. All of these three servers are going to be installed with Windows Server 2012 R2 Standard Edition using a server core installation. I mentioned the virtual machine specifications being different. The SCSI target server Lab1 SAM1 I'm going to build as a virtual machine with one processor, 2 GB of RAM and 60 GB worth of thin provisioned disk. My two hypervisor servers I'm going to build with a better spec, so they'll be virtual machines with two processors, 4 GB worth of RAM and 60 GB worth of thin provisioned disk. As you can see, I'm going to install VMware tools on these servers. Since they're running in a virtual environment with VMware Fusion, this will improve performance. This time, rather than using sconfig, I'm going to use PowerShell. Since PowerShell is Microsoft's way forward, it's worth getting familiar with and becoming confident in PowerShell. So let's configure it using PowerShell. The first task I'm going to do is set the IP address. And to do this, we need to start by getting the interface index for the network card, and then we can apply the static IP address to this interface index. We can get the interface index using either getNetIP configuration or getNetIP interface. So there we can see the interface index is 12. Now we have that interface index, we can use new net IP address with that interface index to set the IP address. Okay, so let's use getNetIP configuration again, and we'll see that the IP address has been set. We can also use getNetIP address. Now it's time to set the server name. So let's check what it is at the moment. It's like a random server name. So we're going to use rename computer commandlet to set the server name to Lab1 SAN1. This will of course need a reboot. Okay, before we finish this server, we still need to set the DNS server to the correct IP address, and also we need to join it to the domain. So let's do that in PowerShell again. And to set the DNS server to be correct, we want to use the same interface index, which was number 12. And we're going to use the commandlet set DNS client server address to do this. And then we can check it with getNetIP configuration, and you can see now that the IP address is correct and the DNS server address is correct. Let's use the add computer commandlet now to join this server to the domain lab1.local. Now that's this server completed, the base build of it, and you need to repeat this task for Lab1 Hype 1 and Lab1 Hype 2. Let's remind ourselves of where we're at. We've built the 5 large servers in the diagram with Windows Server 2012 R2 Standard Edition. We've set up DNS and Active Directory on Lab1 DC1. We've set up Lab1 MGR1 as our management server. And we've done a base build of Lab1 SAN1, Lab1 Hype 1 and Lab1 Hype 2. But there's further configuration we need to do for these 3 servers. The next task, the 6th task, is to set up the shared storage. The 7th task is to set up the cluster Lab1 Cluster 1. And the final task, the 8th task, is to build 3 virtual machines on that cluster. Okay, so let's do the 6th task, setting up the shared storage. As Lab1 SAN1 is our shared storage server, I've now added 2 300GB thin provision disk to it that will be used as its shared storage. This shared storage is going to be shared using iSCSI with iSCSI initiators on Lab1 Hype 1 and Lab1 Hype 2 connecting over IP to the iSCSI target that is on Lab1 SAN1, and from there it can access the shared storage. From now on I'm going to do most of the management tasks from Lab1 MGR1, and to do this I'm going to log in as the domain administrator, and then from Server Manager I'm going to add in all the other servers. There we are, we can see the servers listed there, and we can also see the AD and DNS server, Lab1 DC1. So now we need to add the iSCSI target server role to Lab1 SAN1. And once we've added it, we can then configure it. However, it should be noted that even though I added 2 300GB disks to Lab1 SAN1, our SAN storage server, I never actually configured volumes on them. So once we've done this, we'll configure volumes on them, and then we'll create iSCSI virtual disks on top of those volumes, which can then be shared out. So let's go to File and Storage Servers and Disks. So we can see all our servers listed here. And if we look at the SAN one, you can see the 2 300GB disks I've added. So we need to bring them online, initialize them, and then create volumes on them. So on disk 1, which is 300GB, I'm going to create the volume name of data 1. And then on disk 2, which is 300GB, I'm going to create a volume called data 2. And you'll see then that the space from both of those disks has now been allocated. There's nothing unallocated left. So now we can go to the iSCSI and create iSCSI virtual disks. I'm going to create 3 iSCSI disks, 2 of them on the first volume and 1 on the second. I'm going to create a very small quorum disk for the cluster to use, and then 2 large disks for the Hyper-V virtual machine guest files. So this first disk is going to be the quorum disk, and it's only going to be 5 GB in space. I'm going to set them all as dynamically expanding, and all of these disks are going to be associated with a new iSCSI target called target 1. And then we're going to say which SCSI initiators are allowed, and for that we're going to add our hype 1 and hype 2. I should say that even though I'm configuring all of this through the management server, it's actually happening on Lab1 SAN1. So I am now currently configuring the iSCSI target on Lab1 SAN1. So that's the first disk associated with target 1. Let's create the next 2 disks. So I've already used 5 gig of this, so we're going to assign 295 gigabytes, again dynamically expanding. And we've already created the target, so we're just going to associate that with the same target. So the iSCSI virtual disks are associated with a target, which the iSCSI initiators then connect to and access the disks via that target. And this has 300 gig from the other disk. Again, target 1. So now that we have our 3 iSCSI disks configured, I'm now going to flip over to Lab1 Hype 1 and Lab1 Hype 2 to configure the iSCSI initiator software. Now I'm going to do this exactly the same on both servers, so I'll just show you on Lab1 Hype 1. The iSCSI initiator software is called iSCSI ICPL. And there's a service associated with that, which I'm telling it I want to start every time the server starts. So let's just put the IP address of the target which we've configured. And a quick connect, and there you go, it's connected straight away. And that's all I need to do. That server will now be able to see those 3 iSCSI disks. And as mentioned, I've also done that on Lab1 Hype 2. So let's go back to the file and storage, and let's look at disks, and let's look at our hypervisor server. And there you go, you can see the 3 disks there. The 5 gig one, the 300 gig one, and the 295 gig one. And for each of those, I'm now going to bring them online and create shared volumes for them. And to make this straightforward, I'm going to call the volume name here of the shared volume the same name that I've used with the iSCSI disk. So I should say that even though I'm doing this work on the management server through Lab1 Hype 1, also Lab1 Hype 2 will be able to see these volumes I'm creating now. And then I'll be able to use them in the next stage, which is creating the cluster. The seventh task is to set up the cluster. For this, we need to add the Hyper-V role and the failover clustering feature to both of our cluster nodes, Lab1 Hype 1 and Lab1 Hype 2. As part of adding the Hyper-V role, you can see that it's also asking for more information. With regard to network cards, we only have one network card in our series that is being used for everything. So it's also going to be used for virtual machine traffic, which will go via a virtual switch. It will also be used to send and receive live migration traffic. However, I should say that if we had multiple NICs in our cluster nodes, we would configure this later after creating the cluster. As for the virtual machine hard disks and configuration, I'll leave the default locations as they are for the moment. So let's go to the Failover Cluster Manager and create a cluster. We're going to run the Create Cluster wizard. The first thing to do in that wizard is to add our two cluster nodes, Lab1 Hype 1 and Lab1 Hype 2. After adding both of those nodes, we're going to run the configuration validation test. This will check that everything needed to create the cluster successfully is in place. So let's run all those tests. If we now view the report, we can see if there are any errors that might prevent the creation of the cluster. So we can see some warning against network category. Let's delve into this and see what it is. Okay, so it's only because we have just one network card on both of our cluster nodes. So that's fine. Now we have to provide the cluster name, that's Lab1 Cluster 1, and an IP address. So the cluster Lab1 cluster 1 is now created, so let's take a look at it. You can see that we have no roles at the moment. We've got our 2 nodes, which are both up. We've got our 3 shared iSCSI storage disks. And we only have 1 network, as we only have 1 card in each of our nodes. So we can also see that the disk witness is assigned to the smallest disk, which is correct. But if we wanted to change this, we could actually configure the quorum settings and change the disk that's being used as a witness. But we don't need to do that, so I'm going to cancel. We're going to make both of our data disks cluster shared volumes. And you can see that by doing this, they get mounted under C:/cluster storage on both of our nodes. Okay, before continuing, we're going to rename our cluster disks so that they match the underlying iSCSI disk name. This is just to make things more obvious. In the renaming, I'll also make sure the number matches. So vdisk1 will match volume 1 and vdisk2 will match volume 2. Now we have the cluster shared volumes mounted, let's correct the default location of where our virtual machine files are going to be located. We have to do this per Hyper-V server via Hyper-V Manager. We need to add in both of our Hyper-V servers. Then for each of those servers, we need to go to Hyper-V settings. And for Hyper-V 1, so Lab1 Hype 1, we're going to default its virtual machine files to volume 1. And for Lab1 Hype 2, we're going to default its virtual machine files to volume 2. By having the default location for Lab1 Hype 1 going to Vol 1 and Lab1 Hype 2 going to Vol 2, this should spread where the virtual machine files are stored. Let's have a look at the cluster shared volume file system via Lab1 Hype 1. There we can see the cluster storage directory, and in there you'll see the Vol 1 and Vol 2 and the VMs. I'm going to create a new folder called ISO, where I'm going to copy the Windows Server 2012 R2 ISO file. Since I've got VMware Tools installed, I can copy this straight from my Apple desktop. We're going to use this ISO to actually install Windows Server 2012 R2 in our virtual machines. So under roles, let's create some virtual machines. Firstly, you have to choose which node it's going to start off running from. My first VM name will be Lab1 Server 1. And even though we're not going to change the default location, I've found that we still need to tick the box for the wizard to correctly group the files in a subfolder named Lab1 Server 1. I've also found that for the initial install of Windows Server 2012 R2 to work, we need to increase the startup memory. So let's do that. We'll also tick dynamic memory, as this allows Hyper-V to change the amount of memory assigned to the VM as necessary. We've only one virtual switch, so we'll select that. We'll create a virtual hard disk, and we'll select the ISO we've just copied over from which to install the operating system from. If we now go back to the file system of the cluster shared volume, you can see the files for the new virtual machine are grouped under a folder name which has the same name as the virtual machine's name. We're now going to connect to the display of the virtual machine, power it on and install the operating system. You may need to restart the virtual machine and press a key for the OS install to start. We're going to be building 3 virtual machines, all of them virtual servers running Windows Server 2012 R2. We're going to assign them IP addresses and add them to the DNS and Active Directory domain lab1.local. So let's skip ahead. We now have our 3 servers built. Let's open a command prompt and try pinging one of them. We're going to ping Lab1 server 1 and see if we get an echo request returned. So we're not getting a response. This is most likely caused by the firewall on Lab1 server 1. So let's connect to this server and have a look at the issue. First we need to log in. Let's make the text display slightly wider. 120 characters should do it. We're going to use PowerShell to look at the firewall settings. We're going to use the get net firewall rule to get the firewall rules, and then we're going to use where to filter those rules, looking for any of the rules where the display name has echo in it. We'll also pipe it and filter it in a table format just for easier viewing. Okay, so it's found 6 rules. Let's have a look at the inbound and outbound, and also so the direction of the rule, and also whether it's enabled or not. There we have it. So looking at that, it looks like the VM-monitoring-ICMP v4, that one is the one we should enable. So I'm going to do that now. There we go, you can see I've enabled that rule. Let's try pinging the server again. Oh, fantastic, it's working now. So let's close the console. And let's do a continuous ping to that server while we try a live migration. So there we have it, it's the live migration is completed and the ping has just dropped 2 packets. You have to remember that we're running virtual machines on top of Hyper-V hosts, which they themselves are virtual machines running on top of my VMware Fusion host, which is my Apple Mac machine. So in a live production environment, I wouldn't expect to see 2 dropped packets like that. So there we are, and I've just done another live migration back. And it's migrated it without taking the machine down. And I've just, again, dropped a couple of packets. So that's our ping test done. Let's do one more migration. We'll do a live migration and you'll be able to see the information column this time. So overall now we have the environment built, and I hope you've learned something in trying to copy me and build this environment, and you can now use this environment to practice different clustering tasks, Windows Server tasks, Hyper-V tasks, and I hope you find it beneficial.